Hi, this is Mr. Estrada. In this video, we are going to look at number 38 from the August 2012 Geometry Regents. Chords A, B, and CD intersect at E in circle O, as shown in the diagram below. Secant FDA and tangent FB are drawn to circle O from external point F, and chord AC is drawn. The measure of arc DA is 56. The measure of arc DB is 112, and the ratio of measure of arc AC to measure of arc CB is 3:1. Determine the measure of angle CEB. Determine the measure of angle F. Determine the measure of angle DAC. So as with all problems in geometry, we're going to begin by labeling the given information. So let's start with that. We're told that AD is 56, so we're going to label that 56. We're told that DB is 112, so this arc here is 112. I'm going to label that 112. We are also told that the ratio, now this is important because these are not measurements of the arc, they are in ratio form. So the ratio of AC to CB is a 3:1 ratio. So what I'm going to do is make this 3x, not 3. I'm going to make it 3x because it's in ratio form. So I'm going to write 3x arc AC, and I'm going to write 1x arc BC. Okay? Now, I want you to think about something. What's one way that we can solve for x? Well, we know that all of these arcs, 56, 112, 1x, and 3x, have to add up to what? They have to add up to 360. So I can solve for x by setting all these arcs equal to 360. By the way, in case you're wondering why I'm solving for x, because I'm going to need the measurements of these arcs later on to find what they are asking me to find. Okay, so you're going to combine your like terms to solve for x, right? Because 56, 112, 1x, and plus 3x, that's going to give you 360. So combine the like terms, you get 4x plus 168 equals 360, right? 56 plus 112, that's 168. 3x plus 1x, that's 4x. And we're going to move that 168 over to the other side to get x by itself. That's going to cancel out, and you're going to get 4x equals 192. Divide both sides by 4. That's a 4 over there, believe it or not. Gotta work on my handwriting. That's a 4. So you get x equals 48. Right? So now if x is 48, what must be the measure of arc BC? Well, that's going to be simple. That's going to be 48, right? Because 1 times 48 is 48. What's going to be the measurement of arc AC? Well, that's going to be 3 times 48, and 3 times 48 is going to give you 144. So this is 144 degrees. And that's a 3:1 ratio, right? Because 144 is 3 times 48. Okay, now we got to start to look for some of these angles they're asking us to find. Well, let's go ahead and start with CEB. So angle CEB is an angle inside the circle. Do you see it? Let me highlight that for you in case you don't see it. CEB. It's right over here. It's an angle inside the circle. Now, how do you find the measurement of an angle inside a circle formed by two chords. The way to do it is to take half the sum of the intercepting arcs. In other words, you have to add the intercepting arcs and divide by 2. What are the intercepting arcs of angle CEB, this angle here? Let me remove that there. What are the intercepting arcs of angle CEB? Well, one of them is at 48, arc BC, and the other one is at 56, arc AD. Those are the intercepting arcs of this angle. Arc BC, arc AD. So to find angle CEB, I have to add arc BC and arc AD and then divide it by 2. So what is the measurement of arc BC? That's 56 plus 48 divided by 2. Okay, 56 plus 48 is going to give me 104. 104 divided by 2 is going to give me 52. So the measurement of angle CEB is 52 degrees. Let me just go ahead and remove this since I don't need that anymore. So this angle here is 52 degrees. Okay, now the next part is to find angle F. Angle F, you should notice, is outside of the circle. How do you find the measurement of an angle formed outside of the circle? In this case, by a tangent and a secant. Well, it's similar to what we did up here, except the only difference is that we're going to take the difference of the intercepting arcs, no pun intended. So let me highlight angle F for you. Angle F is right over here. Okay, now let's begin to think about the intercepting arcs of angle F. Okay, so the intercepting arcs of angle F are arcs A, C, B, meaning this whole arc here. What I'm gonna do is I'm gonna highlight it in yellow so you can see it better. One of the intercepting arcs of angle F, the major intercepting arc, is this arc over here. Arc A, C, B. And let's go ahead and just find the measurement of that arc right now, since we're going to need it later anyways. That's going to be 144 plus 48. And that's going to be 192. 192. That's the measurement of the arc I highlighted in yellow. The measurement of the arc highlighted in yellow, arc ACB, is 192. Okay, and you can tell that the measurement of arc DB, which is another intercepting arc of angle F, is 112. Okay, now to find angle F, I have to take the difference of the intercepting arcs. So that was arc ACB. So I have to take arc ACB minus the minor intercepting arc, which is arc DB, and divide that by 2. Arc ACB was 192 minus arc DB, that's 112. 192 take away 112 is 80. 80 divided by 2 is 40. So angle F is 40 degrees. Okay. Now we have to find the measurement of angle DAC. So let's go ahead and do that. Angle DAC is right over here. Do you see it? And angle DAC is what we call an inscribed angle. It's an inscribed angle because it's on the circle. And an inscribed angle is half the intercepted arc. So we're talking about this arc over here. Let me highlight that in green for you. See if I can find a green highlighter. Here it is. So we are talking about this arc over here. Okay, what's the measurement of this arc? That is arc DBC. That's going to be 112 plus 48. 112 plus 48 is going to give me 160. So the measurement of arc DBC is 160. So what's the formula? Well, I kind of gave it to you. An inscribed angle is half the intercepted arc. So I have to get angle DAC, I have to take arc DBC and divide it by 2. Arc DBC, we said was 160. 160 divided by 2 is 80. So angle DAC is 80 degrees. Okay, I hope that helps. Thank you for your time.